NASA has set up base camp in Costa Rica in order to research the composition of clouds and climate, specifically in a tropical region.
We're here in Costa Rica because, one, it has the logistical capabilities for basing the unique aircraft that we utilize, but secondly, it gives us access to an atmospheric region which is called the Tropical Tropopause Transition Layer. Basically, that's a region in the Earth's tropics at about 10 to 12 kilometers, where we find a lot of these strong convective systems, these storm systems. So our ability to understand the processes that occur in this transition layer is inherent to global models of future climate.
This NASA group is comprised of several hundred people, scientists, and technicians who use 3 types of aircraft. The DC-8 serves as the group's in-air laboratory. The ER-2, which flies at around 68,000 feet, that's twice as high as a commercial airliner, is used as a surrogate satellite. And the WB-57, which flies to the top level of the clouds and can study what's there. In this way, scientific readings are taken from the clouds from both ends and from the middle, creating a unique view of these atmospheric systems.
The type of instrumentation that we have here is almost equivalent to taking an MRI of the atmosphere. It's enabling us to probe it in great depths, looking at all the individual organs, seeing how they operate.
The ER-2 is an aircraft that has a bunch of what we call remote sensing measurements on it. Well, we can put this plane wherever we want at the proper time to look at a particular cloud system. So we can put a huge collection of instruments right above a thunderstorm or a cloud that we really want to look at.
The DC-8 is a really great research aircraft for NASA. And we can watch the data as we're going along. It has remote sensing and in situ. So the in situ instruments, like the ones along the wings and the ones sticking out the windows, are to tell us what's going on at the level it's flying. The remote sensors are probing upward and downward to tell us what's going on below and above us.
We've had beautiful flights flying back and forth across these cloud systems as they change. So we're getting some great data looking at the evolution of these cloud systems that are down at the equator.
If he went.
This is incredibly exciting to see this revolution that's taken place and the ability to plan and control these experiments in real time.
Okay.
The amount of data that one can get that way is just astronomically greater than what one could get a decade ago when you couldn't control the airplane.